Yo peeps of YouTube, what's up? Coming back at you with another video pretty quickly, because this time I've made another little device here. This one is a combination of many things. Let's see here. I've got 6 lithium ion battery cells in here, the 18650 cells. We've got 6 down there. We've got an LED lantern core assembly here from something called a Power Advantage LED lantern. It's got 12 LEDs on a little PCB in here, and I'll put you in a stock photo of the lantern here to see what the stock thing looks like. And I modify it because, long story short, the original one that came from, the battery compartment in it takes 4 D-cell batteries. They leaked and they completely destroyed all the metal in there, destroying the functionality of the lantern. So I just stripped it down and took the light diffuser, the LEDs, and the resistor for it out and made this up. I got a little switch here. And you'll also notice back here I've got a USB port. That's right, this thing is a USB lantern. And you notice it works. And even better, I plugged the cable here in. If I can do this one hand. Kind of hard. But there you go, and you see the green light. When it's solid like that, it's charged. When it blinks, it's charging, and whenever it's about to run out of juice, another light on the other side will turn red. I'll throw in a stock photo here of a general purpose type USB battery bank that I sourced the charge and circuitry out of. It's one of those typical Chinese style ones. Throw in an image of the typical type. That image is what they is of an average one. Circuit that I took is similar in shape to the one if you notice the ports on the end there. Because this one I took the output port off, glued it in here, cut the hole there for the charge port, then the output where the USB output port was, started those wires to go to the switch, the resistor, and then to the LEDs. Because 6 alkaline batteries, they run 1.2 to 1.5 volts per cell, so that's 4.8 to 6 volts, so thus USB 5 volt is plenty. Probably could have gotten away with the straight up 3.7 to 4.2 off the batteries, but I wanted to play it safe. So 5 volt output through the resistor, through a switch, to the LEDs, and it's pretty bright. So this is actually born out of necessity, because the other night the power had failed, and I tried to use this lantern, and I discovered the batteries had destroyed the battery compartment due to the leaking alkaline. So thus I made a sort of temporary hack together form of the light, which I'll throw a picture of now. You'll notice that in that photo that I had it USB cable hooked directly to the circuitry that had the original switch on it and resistor, and I had that hooked to that monster USB battery bank, which is sitting behind me right now for power. But I decided that was just a necessity for the time being, but since then I've made this a legitimate light. I know it's a hacked together piece, but it was just made out of junk I had sitting around. You know, I had the switch laying here, I had the USB battery controller circuitry laying here doing nothing. These 6 cells were leftovers, and in fact I've got more of these USB batteries. Here's the original cell that was hooked to the circuit in here, because it was a single cell, and this is the battery off of it. And I got another USB controller board here, the charge output, and this one even has 4 LEDs and a little indicator light on it here, you'll notice. I may hook those together and make a bank or not, I don't know yet. But more lithium battery technology, taking a light that ran off of disgusting alkaline throwaway cells and made it into an economical rechargeable one. No more throwing away cells and destroying the earth from that. Sure, the lithium will finally wear out, but until they do, I just have to plug it in and charge it up, and I can even charge it from solar if I wanted to, as I got USB solar panels, so yeah boy.